Let's go ahead and use the quotient rule to find derivative of a function. So suppose you are given a function as a quotient of two functions, say f and g, and you want to find the derivative of that function. So the way we're going to find the derivative of that function is by simply using this rule. This is what we call the quotient rule. So you keep the function g, which is the bottom function, and this means you differentiate f of x, which is the top function. And then for the second part of this formula, you subtract, you keep the top, and you differentiate the bottom function all over the bottom function squared. This formula can be proven by simply using the product rule and manipulating the formula. You'll get to the quotient rule. We're not going to prove it in this video, but stay tuned for that. So let's go ahead and apply this to an example. Let's find y prime by using the quotient rule for this particular example. So if you want and you want to set up the formula, you can rewrite the function. So y is equal to e to the x, which we can call it f of x, and the bottom 1 plus x squared g of x. Now, sometimes these notation might seem very difficult for you to remember the formula. You can also remember this as follows. You keep the bottom, you differentiate the top, which is f prime, minus, now we keep f, differentiate the bottom all over bottom squared. So that's kind of like the shortcut version of the quotient rule. So you don't have to keep writing g and f are function of the variable x. We can use the prime notation. So let's go ahead and differentiate this. So y prime in this problem is going to be, we keep the bottom, so that would be 1 plus x squared. We differentiate the top, we're differentiating e to the x, minus, now we keep the top, and we differentiate the bottom. That's 1 plus x squared. All over the bottom squared. That's 1 plus x squared squared. So that's how you set up the quotient rule. And now let's take these derivatives. So we're differentiating here, and we're differentiating here. So we have 1 plus x squared. Derivative of e to the x is simply e to the x minus, and then e to the x. The derivative of 1 is 0. Derivative of x squared is 2x. All over the bottom squared. And that completes our differentiation. Now the rest is algebraically simplifying this and rewriting. So I'm going to go ahead and just pull out e to the x from top, because they all have e to the x in common. And this gives me 1 plus x squared minus 2x all over 1 plus x squared squared. And that is our derivative of this function. Let's try out this problem. We want to find the derivative of this function, f of t. So f is given as a quotient of two functions. So think of this as your top, this is your bottom. So we're going to be using the quotient rule to find the derivative. So the derivative of this function is going to be, you keep the bottom, so let's rewrite that, t squared plus t minus 2. And we're going to take the derivative respect to t of the top function. That is t squared minus 1. Minus, now we keep the top, which is t squared minus 1. And we're going to differentiate the bottom function. So that will be respect to t. That is t squared plus t minus 2. All over the bottom squared, that's going to be t squared plus t minus 2 squared. So that's the setup for the derivative into quotient rule. Now let's go ahead and take their derivatives. So this is equal to, you have t squared plus t minus 2 times the derivative of t squared minus 1, that is 2t, because derivative of 1 is 0. Minus, now we keep the top, that is t squared minus 1 times the derivative of this, Well, that's going to be derivative of t squared is 2t, and derivative of t is simply 1, all over the bottom square. That is t squared plus t minus 2 squared. So that is the derivative, but we want to go ahead and simplify just a little bit more. So I'm going to go ahead and distribute here, and that gives me 2t cubed plus 2t squared minus 4t. And then here I will distribute this and distribute the negative. We'll do that at the same time. So that'll be minus 2t cubed, and then t squared, so that's minus t squared. Then we distribute -1 to everything and the negative sign in the front. That's positive 2t. And then -1 times 1, that's -1 times -1, that's positive 1. All over the bottom function squared. That's t squared plus t minus 2 squared. And then it looks like a lot of the things will simplify on top. So I can go ahead and cancel them. So 2t cubed, -2t cubed, they cancel out. And then now here these will combine. So 2t squared and -t squared, that gives me 1t squared. And then 4t, -4t and a 2t, well, that gives me a -2t plus 1, all over the bottom square. That's going to be t squared plus t minus 2 squared. So I'm going to leave it right here. You can play around with it and simplify it more algebraically, but pretty much the calculus part of this question is done. We're able to compute f prime of t.